Today we are starting a new chapter about complex numbers. So we're going to start the chapter with talking about pure imaginary numbers. So our objectives today is going to be express square roots of negative numbers as imaginary numbers, and it has a little symbol I, that's an imaginary number. Simplify the powers of I, and solve quadratic equations that give us imaginary numbers. Okay, so up to this point in math, you have been studying the set of real numbers, right? So we have real numbers, the real number system, and then it broke down. In the real number system, we have rational numbers, so fractions and decimals. And then we have irrational numbers, so it's kind of broke apart, right? Rational and irrational. Irrational is like pi, or a decimal that never ends, that keeps repeating and never ends, okay? From rational, we got integers, which is the set of positive and negative whole numbers. And then from integers, we have whole numbers, which is your counting numbers plus 0. And then from whole numbers, we have our natural numbers, which is our counting numbers, 1, 2, 3, 4, 5, 6, 7. Okay? So, kind of coinciding with the real number system is we have complex. Okay? So here's our rule of numbers, right? And numbers are either going to be real, and then they can fall into any of these categories, or they can be complex. Okay? So this is what we're going to start studying in this chapter, is the complex number system. Okay? So how do we get an imaginary number? Well, the square root of a negative number. So for example, if you ever get the square root of -1, well, the square root of 1 is 1. But what's the square root of -1? There's no two numbers that you can multiply together that are identical will get you -1. It has to be 1 and -1. So this is impossible. So this is what we call, this is not a real number, so we call it imaginary, right? It has the term imaginary. So the term imaginary is what we give to the square root of a negative number. Okay? Just a little history lesson. Negative numbers imaginary numbers have been denoted with a little I. And the person who introduced the little I to us was Euler. So he is a famous mathematician, and he did this in 1777. Okay, so a little history. Euler is our big important mathematician in this chapter. Okay? All right, so let's go ahead and talk about a definition. I want to give you the definition of an imaginary unit. Imaginary unit. So we define an imaginary unit as I, okay? And I, where if you were to do I squared, you would get -1, okay? Or you could say that I is equal to the square root of -1, okay? So the question is why is I squared -1? Why? Why is that? Okay? Well, if we think about it like this, if I is equal to the square root of -1, right? I is equal to the square root of -1, then I squared is I times I. Remember, I is equal to the square root of -1, so the square root of -1 times the square root of -1. So remember, when you multiply two radicals together, you get whatever's on the inside. So you get -1. All right, so let's go ahead and move on. Now that we have this I that we use, it's important to know that from now on, in order for things to be simplified, okay, in order to be simplified, we can no longer have a negative and a radical. If we have a negative in the radical, then we need to go ahead and rewrite it with an I. So for example, if we have the square root of -1, that's not an answer. This is not a simplified answer. What you would say, well, this is actually I. Okay, so from now on, anytime you see the square root of -1, you cannot leave it as the square root of -1. You have to leave it as I. Likewise, anytime that you see I squared, you cannot leave it as I squared. I squared is equal to -1. So from now on, anytime you see this, or anytime you see that, you have to simplify it, okay? So there are other ways to simplify things, okay? So let's say you have I to the third, okay, I to the third. You're like, well, that's not the square root of -1, and that's not I squared. However, I to the third can be rewritten as I squared times I.